Hello again, algebra peeps. This video is designed for just like a little extra practice for just like parabolas in general. What are they? What do they look like? What are some of the features? Like what that sort of thing. So it's really just practice like what should we expect? What are we looking for? What do we like what is it? How do we find these little features like axis of symmetry? How do we find a symmetric pair? What sorts of things are those? So, first of all, here's a quadratic equation right here. The reason why we know it's quadratic, or we'll make a parabola or U-shape, is this right here. That's a squared. Okay, we're looking for that squared. Anytime there's an x squared, you're squaring the x. It's going to look like this. It's going to look like a parabola. It's kind of that U-shape. Right? So here's some kind of function. But right here, this function they've given us right here, this is kind of from like the worksheet we did on Monday. It has the parent function already here for us. So this is actually, let's call this g of x. G of x equals x squared. Okay, so we have the parent function here, and then we're going to compare it to what happens with this one. Okay, so we're going to take a look. Now, before we can really get into this, we gotta get into our calculator. We gotta fill out that table. Okay, so here's our calculator, so we can fill out the table right here. We'll turn it on. Let's see. Let's assume we just turned it on and nothing was there. Y equals. We gotta clear it out. We want to type in exactly what we see here. We're gonna type it in exactly how we see here. X. Let's see, parentheses x plus 1. In parentheses, and then we're going to square it. So here's our square button right here. Okay, so we'll square that, and then we'll say minus 7. Okay, and again, we chose minus for the 7 because it's separating two things, not negative 7. We'll get something completely different if we make it negative. Minus, that's the longer one. That's how you can tell you get the right one. So parentheses x plus 1, end parentheses squared minus 7. Okay, so that's what we want. Second graph takes us to our table. So what we're looking at is we've got these x's here on our table, but we need to fill out the y's, so we need to see what those look like. So we got negative 3, negative 6, negative 7, negative 6, negative 3, okay, and it keeps going. So we've got negative 3, negative 6, negative 7, negative 6 again, and then negative 3 again. And then what I'm actually going to do is I'm going to take this. I want to do one more. I've got 1, negative 3. I want 2, 2. I'm just going to plop that right here. 2, 2. We'll see why I did that in just a second. So I did that, filled out my table. You can also take a look at my graph here. Let's take a look at what we see here. Check it out. There's our U shape. Okay. Compared to this guy, it's moved from our vertex being at the origin to now our vertex is down here. Okay. And we'll talk about what we mean by vertex in a second. So that's what it looks like. Let's put this away. Don't need that anymore. Okay. So now let's do this. Let's plot some points. Negative 1, negative 7, that'd be right here. We've got 0, negative 6 right there. Negative 2, negative 6 right there. Let's see, we got 1, negative 3 right there. Negative 3 is right here. And then we've got this point right here, 2, 2 I added on there. Okay, so 2, 2. Okay, so this is our parabola. Okay, just kind of connect our dots here. Okay, and that's what it looks like. So I know I tell my students, and I know the other students hear this too, that when I see a table that I know is a quadratic, that I know is a parabola, I want to see that rainbow. What do I mean by the rainbow? Well, I mean just this. I'm looking for y's that are the same. So if I have a negative 3 right here, I want to make a rainbow with the other negative 3 that's right there. Okay, I've got a negative 6 right here. I've also got a negative 6 right here. So that makes another leg of a rainbow. Okay, sandwiched in between my rainbow here, this guy's all by itself. but it's okay because it's a special point. This is our vertex. Okay, this is what we call the vertex. So this case it's -1, -7. Right here. I always put a star there. Okay, star it. It's like the star of the show. Okay, it's the only one that doesn't have a symmetric pair. Okay, what do I mean by symmetric pair? A symmetric pair has the same y value. So any one of these legs of the rainbow has a symmetric pair. You got -3 matching with -3. So that means that -3, -3 is a symmetric pair with 1, -3. Okay, so now let's talk a little bit more about some other things here. The equation of the axis of symmetry. Well, what's nice about parabolas is they're kind of mirrored from one side to the other. Okay, so if we look, this side is a mirror image of the other side. So this right side is a mirror image of the left. So see, we've got these points that are right across from each other. Now, this mirror goes right through our vertex. And that's what we call the axis of symmetry. It's a vertical line, so it's x equals. And then that x value of that line is -1. So that's how we come up with the axis of symmetry. Now, how do we put it to good use? Well, if we look right here, these points right here, these symmetric pairs, these ones that are really close to the vertex are only 1 away. And see, they're both 1 on each side away from that axis of symmetry. Here, I've got these two are 2 away on each side. Now right here, I don't see a symmetric pair with him over here, but I know there has to be. So if this one is 1, 2, 3 units away to the right, I have to have a symmetric pair that's 1, 2, 3 units to the left right there. Okay, so that's how we can come up with a symmetric pair. We can also do this thing that I like to call extending the table. So if I've got this 2 that I know has to have a symmetric pair because I already found my vertex, this 2 needs a symmetric pair. We can extend our table. So I'll take this over here. I know that 2 has to match with 2. Okay, because see, -3 matches, -6 matches. I have to match with a 2. But then we just got to look at our pattern in our table to come up with the x. These are all going down by 1 as we're going up. So this would be -3. That would be -4 for that one. And notice we had that point right here, -4, 2. It's right there. Okay, so that's how we can make use of that axis of symmetry, how we can make use of our table and our rainbow. All kinds of good stuff comes out of that. Okay, y-intercept is just normal. Okay, y-intercept, it's where we cross the y-axis. Right, it's just wherever we cross. Right here, it's where x is 0. So x is 0 at when y is -6. So 0, -6. Another thing we get to deal with is called the range. Now you may be wondering, okay, domain and range usually go together, right? Well, range with these parabolas is actually interesting. Domain is not interesting with these things. For all of them, the domain is all real numbers, which is, we just use our big R for that one. Okay, so domain is not very interesting because of those arrows. It's going to go left and right like crazy. It doesn't matter what happens there. But range, that one is interesting because if we look, it doesn't go anywhere lower. This one in particular doesn't go anywhere lower than that vertex. All the rest of our points are all above that. So if we're talking about range, we're talking about y. So we're going to say y. Right? All of our y's are going to be greater than or equal to. Okay? They're all going to be greater than or equal to our lowest y value, which our lowest y value in this case is -7. Okay, that's the y value of our vertex. Okay? Now, before we move on to transformations, something I want to point out. Our axis of symmetry, x equals -1, this -1 here has to match the x value of our vertex, -1 and -1. But then the y value of my vertex and the y in the range also have to match. So it's -7 and -7. All right, so there's another way that our vertex becomes so important. Okay. So now we can talk about transformations. When we're talking about transformations, really what we're saying is how do we go from this parent function, this y equals x squared, where our vertex is at 0, 0, or the origin. What happens to get from that one to this one? What did we do? So there's two things we did here. We went down 7. We went down 1, 2, 3, 4, 5, 6, 7. So that's down 7. And we also went to the left 1. Okay, we went from here to -1, so we went left 1. So if we come back to our transformations, and we look at our transformation notes video, we remember what those look like. Inside the parentheses, we do the opposite of what we expect. That was +1, so that meant we went left 1. Right? We go in the negative x direction when we add. Now, outside the parentheses, our -7, that does exactly what we expect. Okay, -7 means we're going in the negative y direction, which is down. So we went down 7. Down 7, left 1. Okay, there's our down 7. Okay, and our left 1. Okay, so there's the gist about parabolas. Okay, all kinds of good stuff coming from this. Any other questions, just let me know. This is just supposed to be like, hey, a little helpful video. So enjoy, and have a great rest of your day.